Hello and welcome to problem 13 in my Calculus 3 or multivariable calculus problem solving series. In this video, we're going to look at how to solve double integrals over regions bounded by two curves. So let's go ahead and look at an example about how to find the double integral of a surface which has non-constant bounds. So these bounds will be functions in the xy plane. So this example says that f of x comma y, our surface, is equal to y plus x plus 2. And we want to evaluate the double integral of this along the region which is enclosed by the curve y equals square root of x and y equals x squared. So this is what the portion of the region looks like, and it sort of has this leaf shape, and we're going to evaluate the double integral along this region. So it goes from 0 to 1, and if we look at the region with the surface, because the double integral is calculating the volume, it would be like this, and we want to find the volume of this region. So our bounds aren't going to be constant anymore. Because we have two integrals, the bounds on the inside integral will be a function, but the bounds on the outside will be constants. So the bounds on the outside will always be a constant, while the bounds on the inside will be a function. So how do we write the bounds for this? Well, x goes from 0 to 1. So the bounds on x will be from 0 to 1. While y goes from x squared, the lower function, to square root of x, the upper function. So you always put the top function on the top of the integral and the bottom one on the bottom. And so these two bounds give you this region, which is enclosed by the two curves. So our volume, or the double integral, how we want to set it up, will be the integral from 0 to 1, the integral of x squared to square root of x of our function, f of x comma y, dy dx. So the y integral is from x squared to square root of x, and the x integral is from 0 to 1. So now let's go ahead and solve this integral. So this integral is going to be equal to the integral from 0 to 1 of y squared over 2 plus x times y plus 2y evaluated from x squared to square root of x. Remember, when you take the integral with respect to one variable, you have to leave the other variable as, or treat it as constant. So we're treating x as constant in this case, so that's why we got xy here, just like we get 2y here. And so now we have this integral, and we have to evaluate this. So when we do, we get this. And it seems a little long, but it's pretty easy because this is just a big polynomial. And some of the stuff ends up canceling. So we find that we have the integral from 0 to 1 of x over 2 plus x to the power of 3 over 2 plus 2x to the power of 1 over 2 minus x to the power of 4 over 4 minus x cubed minus 2x squared dx. And when we take the integral, we get this, and we have to evaluate it from 0 to 1. And we know that when it's 0, the whole thing equals 0 because every term has an x. So when we plug in 1, we get 1/4 plus 2/3 plus 4 minus 1/20, 1 over 20, minus 1/4 minus 2/3. And we see that these terms cancel out, and we are left with 4 minus 1 over 20. Or 80 over 20 minus 1 over 20. And so our final answer is going to be 79 over 20. And so this is what our volume is going to equal. So that's all for now. Thanks for watching.